JBL EON210P mixer power amplifier, claimed or rated at 300 watts, 2 times 150 watts per channel by JBL, with the old Crown amplifier. Nothing like that really. What does that mean? Music watts, peak power? Who knows? We'll test it one day and we'll debunk their figures. But in the meantime, this one's from someone, YouTube viewer actually. He said he was using it. They went out for a fag break during halfway through their practice session, came back and it was dead. And I'm not surprised. I fixed maybe 20 of these, I suppose. I don't know. Anyway, I'm just going to pass this on. So I've taken all the screws out. You can take it apart, and first thing that comes off is this, just this plastic surround, and then the mixer, which is a Soundcraft mixer. The mixer is excellent, by the way, very good. In fact, I'd actually consider just putting a small power supply in there to power the mixer and just put some differential outputs on there for driving an amplifier rather than using the amplifier within. Okay, but the amplifier is reasonable, Crown amplifier class D. Then this comes off, and there's a metal cam which I've taken off already, which covers this horrific design under here. And I'm not going to waste too much time on this because I already got the meter out and checked across the FETs, and they're blown. Basically, we've got blown FETs, and this one's a variation on a theme actually. This one's got the FAN MX7387 management chip, and it's a really crude management chip. I'll put the datasheet up in a minute, you can have a look at it, but it's really designed for driving fluorescent lights, and they've used a real budget power supply in this. Got the 7387, which is the self-oscillating FET gate driver. Let's get something to point with so you can see. Shall I zoom in on that so you can see it a bit better? Let me just do that. Right, the main purpose of this video is to reiterate what you need to change, okay, and what the values are and what the components are, so that you know. So that's just straightforward 10 ohm resistor, 1210, alright, 5%. That one is supposed to be as well, but obviously someone's changed that for a slightly different version, but you might as well put the right one back in. This one is 49.9 ohm, 0805, that one. This one, what does that say on it? 85X. 85X is 75 ohms. That's a 75 ohm 0603. This one here is 49.9. You need to change that, and obviously that's 10 ohm. Okay. Now K1Y is, which one of these two is it? I've got the transistors out of the drawer at the moment. Right. So okay, K1Y. And if it's yours are blown up, they might not have the K. So there's the K there. Look, that's the K1Y, and that one's a K1Y. So they're slightly askew. That's a K. Is that a K? Let me get the magnifier on that just a sec to make sure I'm telling you the truth, because I'd hate for you to blow it up on basis of bad information. Yeah, that's okay. So your K1Ys are that one and that one there. So Q604 and Q605, is it? Anyway, it's that one, right? And it's your MPN, and the transistors, this one here. Buongiorno fuckers every day. So that's Farnell order code, and that's the part number, right? K1Y NPN, right? Alright, and then the other ones are the J1Ys, which are this one and that one. This one here and that one there, a J1Y, and that's the part number coming into focus near screen soon. Yeah, 2453936, and that's the part number. That's the manufacturer's part number. PNP, and they're a complementary pair, okay, so you need those to change those, alright? Then you've got the MX7387 management chip. Change that, and if you don't, you should. Did I mention this one already? 49.9? If I didn't mention that one, it's 49.9. And then I always change these. I don't muck about with semiconductors. If it's been gone bang, who knows what's gone. And for like 25p or something, LM393, which you know about, that coil there I put high voltage coil in, and then down here you've got the LNK chip. If you see it, change it. Don't even leave that in the piece of kit, alright? And change that cap too, alright? If you change all those, and of course the transistors or the trench drop diodes, whatever under there, they'll be identifiable fairly easy, I should think. I'm going to take this one apart in a moment and then I'll know what to change. But obviously you've got to change both of those. Even if one of them's shorted, change both, don't leave them in. And the only other component you need in the single, this has got a single channel amplifier on this, I think, or has it? Do you know what? I don't think it has, unless they're the diodes. I'm not sure. I'm going to look that up in a minute, and if there's anything interesting I'll add it onto part 2. But over here there is that one, 10 microfarad capacitor. Change that. Not happy. I use the Panasonic ones. If you look at my other videos, the Panasonic range which I use for that is detailed there. I might put the data sheet on the screen briefly so that you can see the best type to use. Anyway, so I hope you found them interesting. All the power goes through that cap. Right? So if you open up one of these, change that cap. Change that cap. That cap, self-healing, eats away to nothing. I'm pretty sure, if I'm wrong, that's some of them are connected directly. The actual switching point is driven directly into there, but it would make no sense from the efficiency point of view to do it that way, because it's a resonant tank circuit, I think. So I think that all the power is transmitted through that cap in the form of an AC waveform to drive that transformer. Much more efficient, alright? So what I'm going to do is I'm going to change this capacitor, because if you've got the thing open, you might as well change the cap, otherwise it'll go later on. I'm going to change the FETs under here, so that means taking everything off the heatsink, change this, the FET under there, or the transistor, whichever it is. Alright, so I don't think I've got any 7387 chips in stock at the moment, so it looks like I'm going to have to go ahead and order some. So I'll swap all those components out and then test it. But yeah, that's what's inside the EON210P. Great sounding device with schoolboy design in the power supply section, I would say. God knows why they don't improve their power supply design. Come on, people that make PCs can do it, can't they? They should have taken a Dell personal computer circuit and just changed the output winding ratios, and you'd have a totally reliable system. But no, terrible. A travesty. Anyway, so if you want to subscribe, have a look, tick down there and subscribe. If there's anything particularly interesting on this in terms of the parts are replaced and it doesn't work, I'll create another video and look out for part 2. And on part 2 there will be more detailed fault finding if required on this power supply. I don't think there are any vias that I've seen before where the vias that connect the layers blow open circuit, but when there's a fault condition on these, often you get tracks blown open. So you change all your components and they still don't work, and it's because the wiring board is no longer the same circuit because the vias have blown open. They've done, again, schoolboy design errors of putting power down vias, a single via, which is absolutely bonkers, really is. The more I repair, the more blown vias I see, the more angry it makes me, because it's just so unnecessary. It's the engineer has got someone else to route the circuit for him probably, and not really the person that's doing the routing isn't really up to scratch. So if you're listening, you need to find someone who's going to do the routing correctly on your PCB layouts, and then you'll find yourself in a much more comfortable position with regard to the relationship with your customers and the perception of your products in the marketplace, and less going into landfill, of course. I shouldn't complain really, I'm a repair engineer, so why complain? But it's just unnecessary. There's far too many of these for me to repair personally in the marketplace. And there's a capacitor missing off here, look, as well. Someone's taken this off and there's one of the caps is missing, which is interesting. It's just snubbing the output, which is a high frequency bypass capacitor for the, what was that missing on that one too? No, it's on that one. Okay, well that's it. If you've got any questions, and ask. I haven't got a schematic for these, but I know how they're all wired together. And I certainly know, if you look in some of the other JBL schematics, you can see the arrangement of this Darlington pairs driving the actual output transistors for the power supply. When the power supply blows, it generally doesn't blow up anything on the secondary side, i.e. the amplifiers or the DC power supply on the secondary side. It's usually isolated to the mains high voltage side on the main side. So there you go. I hope you enjoyed that. Thanks.